Assalamualaikum warahmatullahi wabarakatuh.
Hi everyone, I'm Akila.
And I'm Nazwa.
We are from
SMA Semesta Semarang. On this occasion, we would like to present our project with the title WHYCONS, Water Hyacinth and Coconut Fiber Nanofiltration Straw.
Manufacturing activated carbon-based nanofiltration straw from water hyacinth and coconut fibers to overcome iron contamination in household water. For humans, water is not simply a vital need to our bodies. It is also a resource we benefit from every day.
Unfortunately, changes in the environmental condition make the reduction of water quality and availability. One of the examples of water contamination found in Dusun Kepoh, Gunung Pati, Semarang. The water for household purposes there is yellow, smells, and has corrosive deposits. And it was found that the water contained iron.
Contamination of iron in water can cause health problems and environmental problems. So one of the methods that can be used to reduce iron contamination in water is by adsorption. Adsorption is the process of adsorbing fluid particles by a solid adsorbent.
In this research, we use coconut fiber because it contains lignin, cellulose, and hemicellulose. Meanwhile, for the water hyacinth, it can form phytokeratin, which is a peptide compound that can bind large amount of metal ions.
On the other hand, we choose coconut fiber and water hyacinth is because their availability is abundant in the environment, so it can cause environmental problems such as eutrophication. Next, we use nanoscale to increase the adsorption surface area.
Based on the background, the problem can be formulated as how are the characteristics, how effective it is, and how to design it.
Next, we're going to explain about the research procedure. So the first one is by making carbon from water hyacinth and coconut fibers. We use microwave to make it and then grinding it into nanoscale.
And the second step is determination of maximum adsorption capacity of those carbon to iron ions.
And the third step is characterization of nano-coconut fiber and nano-water hyacinth by using infrared spectrophotometers.
Then the last step is to design the WHYCONS.
Next is the result and analysis. So the first one is characterization of nano-coconut fiber and nano-water hyacinth. So from there, the morphological structures of nano-coconut fiber consist of fibers, crystals, and filaments.
And for the water hyacinth, it consists of fibers and filaments.
And for the functional groups of both carbons, there are methyl, hydroxyl, and carboxyl group. And there's an electrostatic interactions that occur between the iron metal ions with the negative group of carboxylic acid. So the iron can attach on it.
Based on our result, the nanocarbon has a size of about 2 until 3000 nanometers, which can work within 60 minutes with a higher coconut fiber ratio of 7:3 because it can absorb around 97% of iron in water.
The following is the design and our final project, WHYCONS. Our project is made of water pump complete with a lid that has a water hose which connected to a water pump. Inside that, there's a combination of nanocarbon from water hyacinth and coconut fibers with a ratio 7:3 that packed in tea bags to prevent the carbon particles being carried along with the filtrate.
The filtrate was then tested using potassium thiocyanate and sulfuric acid to check the presence of the iron. The sample we took from Dusun Kepoh contains iron because of its yellowish color. But after we filtered it using WHYCONS, the water did not contain iron anymore.
So the conclusion of our project are: the first is the morphological structures, the functional groups, and the carbon particle size supports the carbon to adsorb more ions in the water. And the second is the adsorption effectiveness of the carbon is in ratio 7:3 because it can adsorb until 97% of the iron in the water. And the third is the WHYCONS can be used to reduce iron contamination in water.
And suggestion for further research, it is necessary to pay attention to the selection of the right pump, pipe, and modify the use of current so WHYCONS can work more optimally.
For our future research, the strength of our products are it is made from easy to find materials and you don't have to spend a lot of money if you want to make it. But the weaknesses, it doesn't last long. If you use it a lot, the carbon parts wears out and you have to change it into the new one.
Furthermore, our product faces challenges due to competition in water filter market. Even though it has weaknesses and threats, our product can be developed into further research and can be a form of waste reduction movement.
So that's all from us. Thank you for your attention. I'm Akila.
And I'm Nazwa. Because water is life.
So don't forget to maintain our life.
WHYCONS?
Why not?
Wassalamualaikum warahmatullahi wabarakatuh.